来 share，现在找一下我这边的 screen sharing，好像是这样子 share 吧，我试一下看看能不能看得见。如果我把它全屏的话，这样大家是可以看得见的吗？
可以。
可以。
好，perfect。So here we are exploring the applications of multi-agent systems. Um, So the goal here is to we are trying to explore the applications in different scenarios, and we build several chatbots, like chatbots for technical support, for phone plan recommendations, and also for travel assistant. And here is a very general overview of what we did and what we want to do, because it includes several chatbots. So later on, we will have more specific introduction of each of them. Here is the general direction of what we are doing. Is because there are many tasks involving complicated decisions and actions, and it's hard to automate them. So we are looking for this scenario, application cases, and trying to build multi-agent workflow AI pipelines for them. There are a few application cases, such as a chatbot for customer support. When the query becomes complicated or needs a complicated thought process, we can use the multi-agent systems. And also there are some other applications like vehicle coordinations, financial analysis, recommendations, and robotics. And here we have chatbots in customer support and the recommendation. Here we are just re-emphasize what is the multi-agent systems, the role of it, and advantage is apparently improve the performance, enhance customer satisfaction, streamline process, improve operation efficiency. On the other hand, it can also reduce costs because it minimize the human resources and operational cost. In all our chatbots, we use the long graph as the framework to build the graph-based multi-agent systems. We use the React as the front end and the fast API as the back end. Just in case, because we are learning the multi-agent system. So here is a very high-level overview of what kind of framework it could be. It could be decentralized, centralized in different architectures. And in our case, I believe all the agents are based on the layered architectures. So they have some there will be an agent with manager roles for planning, for task assignment.
Which architecture are you using? So there are multiples here.
Which one? We use the top left one, the layered, the one on the very left top. That's the architect.
Can you elaborate on what's their advantages for the different architecture?
I'm not actually not sure. And in our case, it's just the logic thought process become easier in that way. So once the query come in, we kind of can classify it and assign the tasks and then further process it. So it's kind of a good application in this case and a good structure in this case. And I would assume we used to fund a project for auto bidding system. I would assume decentralized one is better for auto bidding. So different agent bid for different prices and compete with each other. Yeah, that's my thought process.
I think the logic here is that the architecture of your agent system should comply with your workflow,
Right.
right? So because I think the layered system is that you have some query, and then you are expected to get some result, and so it's a layered system for decision making, basically.
Right.
I think the more complex the system is, that probably the decision process is more complex. So I think that is something for the layered architecture.
Mm.
Uh, and the centralized system, you can see that. So it has a central point, right? And it has many satellites. So
Right.
that is basically first you can do like a broadcasting. So if you have one message that is sent to the central part, and then it can broadcast it to others, and it can then when the different agent process the signal, it can send the outcome back to the centralized part. So that is more like a parallelism system. It has different tasks, and you have a central point to assign all these tasks, and the other satellite agent can deal with that, right? So that is the centralized system, and it's very similar to the lower right one, like you share the message pool. You it's very similar, but I think in terms of architecture. And the decentralized one is that uh, every agent will communicate with other agent. So that would be different from the centralized one. So basically that any message, so any agent can talk with anyone. But the problem with this architecture is that it would be very slow. So the efficiency would be very slow because uh, basically you need to talk to a lot of other agents to finally make the next step. So they have different pros and cons, and they are suitable for different kind of tasks. Yeah.
Yeah, so may I ask a following up question for this? So what kind of a classic application for centralized and decentralized? I understand the concept, but what's the classic application of them?
I think the centralized one is just like a multi-task parallelism. So you have different tasks, you can assign it to different agents, and they can finish it directly and
Mm,
send it back. Uh, so yeah, it's
okay.
very basically all the parallelism code before, like a MP multiprocessing. So it has a lead node, right? So that is the centralized part. So it's very similar to that architecture. And the decentralized one, like the blockchain we are using today. Uh, so and the decentralized one is like a, I don't know if you have ever heard of like the federated learning, and for financial institute. So each customer, they want to have their own data that is uh, totally, I think, secure, right? So you want all your data to be contained with yourself, but you need to do some computing, and you need to do some communication with others, right? How are you going to do that? So that is this kind of architecture changing. So you have a federated part, that one agent can take care of your own data. So you just talk to this agent, and this agent can communicate with other agent that other agent can help
我
you
没
finish.
事儿，我一点儿一点儿来，要不然我这案板放不下，我那个
Okay. Yeah. So that is like a federated learning. So you can look that up. Yeah.
Oh, yeah, I will surely look it up. Yeah.
Yeah.
Okay, then I will move forward to the next one. So the first part is the technical support chatbot. So the challenge we are addressing here is that for complicated software or hardwares, their manual could be very lengthy, could be 100 pages. I mean, a lot of manuals, each manuals could be 100 pages, and the user need to go through them. And it's hard to train all the users to be proficient to easily operate some software and hardware, especially in semiconductor industry. So consider complexity. So here we are developing a technical support chatbot. So basically, it's doing two things. One is helping customer understand the systems. If they have something they don't know, you can quickly get the answers, relevant answers. And second thing is that to operate systems, we always need some recipes, some parameters need as the input. So we want to generate the optimized solutions recipe to our customer. So that's the drive. That's the drive for the application. In order to do this, we first try this specific architecture. We do have a different variants of the architecture, so we added different modules in different versions, and we don't have the time to really converge all of them together and make them complete. So here is a kind of an example of one architecture. We can go through it together at a high level first. So once the user have a query, it will go through a guardrail, which is not shown here. Go through a guardrail, check whether this query is reasonable, it's fell in the scope of company's policies. Does it ask reasonable questions? After that, there will be an agent to decide what's the best way to handle this query. This query could be about what our company is specialized in. For example, we have some proprietary database which provide professional solutions, recipes to our customers so they can use as input, or have some proprietary information about the system. So that's the decision, and the planning agent, which is called analyze and route query here, the module, will make the decision and route it to the research plan route. And it will go through research and generate a response. And of course, we also want to provide customers some insight beyond what we have, because sometimes our database may not be up to date. And so some new feature get released, and there are also a lot of good insights from, for example, the publications, the database, beyond our company's database. So we have a React agent node, and for the React agent, right now, what it's doing is only have an online search tool. So once the query comes in, once the planning agent decide it's not really fall into our database scope, then it will go to the React agent to search the query online and perform some have some iterative process to deliver some good result. We will dig into the research agent and the React agent later on. And of course, sometimes user may not really clarify their question in the right way. So we have another module for ask for more information. So if the information message is not complete, the chatbot can ask following up questions to help customer clarify what they want. After understanding what they want, we can better make a research plan or make a plan for the online search. And also, this module can also just have a prediction from large language model using the kind of the knowledge stored in the large language model. Here is an example of what it's doing. So right now, the database and prompt we are using is actually based on LangChain. So we can imagine this is a LangChain, a customer support chatbot for LangChain. And in this case, specific examples, our customer asked a message, which is not showing here. It's about asking the most recent features or functions in the LangChain. So the planning agent will route to the React agent node and provide some most recent functions. And sometimes, just in case the chatbot provide misleading information, so we have provided the guardrail at the top and the bottom. And in this schematic, we only see the guardrail at the end. So basically what it's doing is if our customer asks some very strange question, in this case, saying our competitor is way better than our company's product, then hopefully the chatbot will not produce any misleading information, will not promote our competitor's product. And here the answer is the structure, basically saying we cannot provide any information about other AI framework.
Did you apply these competitor filtering yourself?
Yes, we applied it at the top and the bottom of the framework, the node.
Okay.
Does it make sense?
I just don't know why you take Crew AI as your competitor.
Oh, okay. Sure. Yeah. Well, yeah, it's maybe I just feel it's one of the choice for the for the AI framework. But Crew AI is actually built on top of LangChain, is that right? So yeah, maybe I should use some the other information. Yeah, but this is the concept of it.
Okay.
Yeah. And of course, the main application is to dig into our the company's proprietary database. And in this case, it's kind of enhanced RAG. And in this case, we used the LangChain documentation as the database. And we performed the research to so basically user is asking, okay, what is LangChain? Give a basic introduction about its functionality, etc. And you can dig into our database, which is about the LangChain, and then provide answer after research. So this information is from the database. To further explain what's happening here, so once we classify user's query as a query relevant to our database, need our proprietary information, then we will first create a research plan composed of different questions, kind of to enhance the question and make a better retrieval. After we enhance the query, it can source different documentations, and for each query, it can generate several to retrieval, and we can synthesize all of the answers to all of the information together, and provide an answer to the question. So this is the role of the researcher. And it's just we just zoom into this conduct research module, the researcher module, and show you how this agent really work. It generate queries and retrieve documents. And for some queries that need a very specific some information other than the database, it will route to the React agent. And the tools here is the online search tool. So this is the logic of this React agent. So basically, first it's analyze user's query and decide, okay, whether we need to use the tool or whether we just answer it. And the tool here, we only have one tool here, which is the online search. And in the future, we can add some other specific tool, maybe some tool for some other database. And so it will evaluate its answer and continue this process until a final answer is reached. So in this case, it can playing a role to make sure the answer is optimized. With limited time, we build a front end and we have a back end. So in this case, we use the Fast API for the backend and React for the front end, just because it can is scalable and has a rich user interface and can be integrated together. The second part is the phone plan recommendation chatbot. So our teammate may present this part.
我用中文讲吧。
好。
这个就是一个纯粹的chatbot，我觉得它都不算是一个 agent，也不是基于那个擎天柱他刚刚讲的那个 long graph 的那个复杂的结构，这个只是一个很简单的一个 node，有一个 chatbot 在里面，然后做这个的初衷，做这个项目的初衷是。因为我现在工作的公司，它是一个 wireless 的5G network wireless 公司，所以我们会和 ADT 啊、AT&T、T-Mobile、Verizon 这些公司竞争我们的网络，所以我们公司是已经研发出了一个 chatbot，就是回答回答回答客户，比如说他们想要什么样的。他们想要什么样的套餐，然后根据我们公司所有的已有的套餐推荐给他们最适合他们的。然后我这个呢，我就是把不同公司，把我们的竞争公司他们的一些套餐的数据也想要也弄过来，然后比较不同的公司的一些套餐、一些价格，然后给客户提供一个选择。这个也是基于 long graph，然后可以用 OpenAI 的 API，也可以用 DeepSeek 的 API，然后再用 Fast API 做一个后端，然后 Gradio 做一个前端，一个 Web UI。对，然后还有一个我想说的就是，哎，天柱可以看下一页是什么吗？哦，这个是一个 chatbot，对，就是这个的话，其实是个很简单，然后我都没有用 RAG，因为我就是把我的那些收集的一些数据都放在 prompt 里面，一个 prompt template 里面，告诉他是一个
你有数你那个 prompt 有多长吗？
那个 prompt，呃，那个 prompt 有多长？没有，我没有放很多 进去没有很长，我没有数有多长，但是没有很长，但是我知道这是个问题，因为我发现我用这个 chatbot 多问几个问题，然后他就说超过他的那个context window 那个 size 了，他说
对对
因为你的 prompt 太长了。
对，
对，所以这是个问题。我觉得最后，所以要改进的，就是要把这些数据都用 RAG 的方式，这样的话应该就会避免这个问题吧，我觉得
是的。
是吧？对，所以我就说这是一个很 basic 的一个 chatbot，然后也是可以执行，就是可以在这个界面里面问很多问题，然后它可以回答。对，我这个就感觉在推销我们的公司。Anyway，嗯，所以
那我问一个问题啊，那
啊，
就以你现在 show 的这个问题吧，就说我想要去有一个 budget friendly option under 15，他为什么要给我推荐这个呢？
我觉得对
因为
了，你的意思是它有没有比较？
因为你15块钱，我还听那什么 Mint Mobile，它也有15块钱一个月的，那为什
嗯，
么没给我推荐 Mint Mobile？
对，这可能是我的那个 template 那个数据没有全面。
啊，没在你那里
是，
头。
对，没有在我的里头，我那个，所以我那个数据也就是因为我应该是编的数据。
啊，
对对对，如果真的有，如果公司要做这个的话，我肯定是首先我们公司自己的数据肯定是有的，然后 competitor 的数据我们肯定是也要收集的。
嗯
对，这个只是为了 demo。
OK，
对，嗯，最后我觉得最后 future 的话，应该还是如果能做成一个 agent 加更多的 tool，然后能够比较不同。能够有一个比较的功能，比较不同公司，他们根据你用的 data 的量，还有你要去 global 要去旅游用 international roaming 这些东西，给客户提供一个最 optimized 的一个 plan 的话，可能需要加更多的 tool，对，但是可以改进的地方，然后肯定不能把我的这些数据都加到 prompt 里面，对
嗯
对，这
嗯，
是我也是在学习中。对，这就
好，
是应该就是一个整个的一个 presentation 吧。
好的，好，谢谢你们。还有这，
那我再切回来，我继续介绍第三个。
好，
好，先谢谢这个晴雯的 presentation。然后我其实用中文做 presentation 很少，所以我还是换回英文吧，这个 natural 一点。嗯，Okay, so let me introduce the third application, the travel assistant. So here, the goal here is to uh, provide a travel agent to perform different tasks. So this is a quite ambitious task. So it's kind of the larger plan. So what we really achieved here. So this is a example of the architecture. It's kind of a revised version of the architecture we used to have for the first agent system. So similarly, after user query, we classify it using large language models. We could either ask more questions, provide travel suggestion directly, or generate a travel plan and then use the proprietary database that we have stored in the company to provide the customized the solution for travel. And Of course, we also provide several logics here. So based on there's a note whether it has the destination. So basically different way to classify the queries and to go through different route. And we also implemented a simpler version of the travel assistant, which is like this. So basically we we basically revised it based on the React agent we talked about in the first agent system, and we added a agent between the start and the core model, which is the agent to memorize users' preference. So beyond the basic React agent, what it can do is, if user provides some negative, very positive or very negative response, it will memorize users' preference and provide customized solutions. The example would be, so for if we ask the travel plan for San Francisco for the first time, it will provide some very classic place to go, Golden Gate Park, the Golden Gate Bridge, this kind of very classic place to go. But if we tell him, okay, I stayed here for 5 years, 10 years, and so these places have been visited. So the chatbot will memorize this preference, and if we ask the similar question later on, where should I go in San Francisco? Then it will provide some very customized solution for local people. So in this case, there are some different events, different hiking places to go. And okay, I think that's all the agents we have been built, and some of them has been deployed, some of them are still under testing, and we still need a bit more time to polish it to make them be more functional. 好，谢谢。
好，谢谢。大家有什么问题吗？我看黄素师兄已经答应了。师兄，你有什么 comment 吗？方不方便说话？你那边？OK，那就是不太方便。那行，我先稍微给一下 comment 啊，我会从几个方面来evaluate 你们这个 presentation。我先说 highlights 吧，我就觉得你们的 flow chart 做的非常好，就是整个 present 的这个，对，就这些 flow chart 呀，然后包括前面的你说各种各样的一些 background 的一些介绍的那些图，我觉得这个做的非常的好，然后这个是一个非常大的优点。然后呢，我觉得 business 上呢，你说的 application 一的地方 business 我不太知道，然后后面两个我是比较能够清楚它是在干什么的，就不管是 travel agent 呀，还是你这个倒数第二个的那个5G 的网络的推荐的，对，这个都是非常明确的，我觉得这个三个里面我两个我觉得是非常明确的。然后像这个5G 的这个，我觉得你这个故事是非常好说的。travel agent 的话，呃，你如果要去跟别人说你为什么要做这个东西的话，可能就相对没有那么好说，对吧？就你怎么会想到说你想要去做一个 travel 的一个 agent 呢？所以这是另外一个问题。然后我觉得比较 missing 的一个 part 呢，就第一是这个 metrics，就是你怎么知道你做出来好还是不好，这个是完全没有。然后第二个呢，就是你这个 actual 的一个 demo，这里是没有的。因为我其实是希望在最好的一个情况下的话，就是你甚至于可以把它给 deploy 出来，然后让别人可以直接用，这是一个最好的一个状况。对。呃呃所以就是从这几方面来 comment 一下。那整体来讲还是不错的啊，就是说你们这么多，你们做仨是吧？做了3个，呃 就不错。那其他人还有什么问题吗？没有，没有。好，那谢谢。那我们就下一组吧。下一组，book recommendation agent。